Okay, if you were absent on day 1 of chapter 9, or you're just a little bit confused about what we're doing with finding the key characteristics of a quadratic function, then this is the video for you. You should have already completed, before you watch this video, the first couple pages of your notes that look like this. If you were absent, here's what you're doing. These are examples of things that are quadratic functions. These are examples of things that are not. Then I want you to look in this big box down here and circle all the ones that are a quadratic function. So you're looking for a pattern. What do all of these have in common that these do not? Alright, and then you're going to define a quadratic function, and this goes on for 7 different words. So you're going to go all the way until you get to the page. You're going to define all of these, and then when you get to the page that has a table on it, that's where you can stop and come back to the video. So if you haven't already completed this part of the notes, you need to go do that now. Okay, so once you have finished that part, now we're going to fill in this table. Make sure that we have an accurate definition and that we understand what these things are and how we can find them. So a quadratic function, hopefully you figured out from that page that they have to have an x squared, okay? And that has to be the highest exponent. The word that we have for the highest exponent is degree. So quadratic functions have a degree of 2, which means that the highest exponent is 2. Also, you should have noticed that you can't divide by a variable. Okay, so we can't have something like 4 over x squared. That would not be a quadratic function. Okay. The next word that you had to define was vertex. Okay, so the vertex is the point on the graph where it changes direction. So if I have a graph that looks like this, my vertex would be right down here at the bottom because I'm going down, 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 down. Then once I get to the vertex, now if I keep going, I'm going up. Alright, so it's either the lowest point or the highest point, and it's the place where it changes direction. Okay. Now in this chapter, how you write things is very important. So you need to understand that the vertex is a point, which means anytime you are asked for the vertex, you need to write an ordered pair. And here's how we find the vertex. This handy little formula, x equals negative b over 2a. Alright. Where did b and a come from? Well, remember when we were factoring and we wrote our equations in what we call standard form. So ax squared, a can be any number, plus bx, b can be any number, plus c. So that's the way that we wrote our equations. So b is going to be this number right here, which is the coefficient of the x, and a is going to be this number that's the coefficient of the x squared term. So let's do an example. If I have x squared plus 4x plus 12. Okay. If I'm going to find the vertex, all right, I need to identify what a and b are because they're in my equation. So b is the number that's next to the x. It's going to go on the top, and in this equation it is 4. So on the top I have negative 4. Then on the bottom it's negative b over 2 times a. Okay, so a is the number in front of the x squared term. Here, there is no number, so remember when there's nothing written, we know that it is a 1. Okay, so I have 2 times 1 on the bottom there. Alright, if I simplify this, 2 times 1 is 2, so I have negative 4 over 2. Negative 4 divided by 2 is negative 2. So I have the x coordinate of my vertex. It is negative 2. But my vertex is a point, so I need the y-coordinate as well. To get the y-coordinate, I'm going to plug negative 2 into the equation, alright, so that I get the y-coordinate. So now I have negative 2 squared plus 4 times negative 2 plus 12. Alright, negative 2 squared is 4. 4 times negative 2 is negative 8, and then I still have plus 12. So 4 minus 8 plus 12 would give me 8. So my vertex is negative 2, 8, and I write it as an ordered pair, and that is my final answer. Okay, so to find the vertex, we have x equals negative b over 2a. We're going to take the numbers from the equation and plug them in. That gives me the x-coordinate. If I plug the x-coordinate into the equation, then I get the y-coordinate. Alright, you also were asked to identify the min and max point. Alright, hopefully you know the words minimum and maximum. So the minimum is the lowest point. The maximum is the highest point. Okay, what is important to note, so we we looked at graphs, okay, to find the min and max point. It either opens up or opens down. These graphs are known as parabolas. That is what the shape is called. So when we graph quadratic functions, they make this U shape, and this U shape is officially mathematically called a parabola. The min or max point then would be the lowest or the highest. What is important is a parabola can only have one or the other. It can have a minimum or it can have a maximum, but it cannot have both. Alright, so these are points. These are ordered pairs. Okay, if it's on a graph, you just look at it and find the point. If you're given the equation, the min or max point is also the vertex. Alright, if you look at, that's where the graph changes directions. So to find it, we're going to find it the same way that we found the vertex. Alright, so min and max point, find it the same way as the vertex. Min and max value, alright, so this time instead of the whole ordered pair, we were just looking at the y-coordinate. Alright, so it's the y-coordinate of the min or the max, which is also the vertex. Alright, so the y-coordinate of the vertex is your min or max value. This time this is a number, so we're not writing an ordered pair, just a number. But because it comes from the vertex, we're going to find it the same way. So you would do x equals negative b over 2a, find the x-coordinate, plug it in, get the y-coordinate, and then that y-coordinate would be your answer for min or max value. Alright, axis of symmetry. Okay, it is a vertical line. Alright, and that vertical line has to do two things. It has to pass through the vertex, and in doing so, it cuts the parabola in half. So if I have my parabola here, my axis of symmetry goes right through the vertex, and on either side of the axis of symmetry, they would be mirror images. If I could fold my quadratic along the x-axis, these two sides would line up perfectly with each other. Alright, because the axis of symmetry is a line, it is an equation. So when you're writing answers, your answers need to be an equation, and it's in the form of x equals, because x equals is a vertical line. Alright, now the axis of symmetry goes through the vertex, so guess how we're going to find the axis of symmetry? X equals negative b over 2a. Alright, and then whatever number you get, that will be your answer for the axis of symmetry. Okay, then a little bit of review of things we've talked about before. Y-intercept. Okay, remember the y-intercept is where the graph crosses the y-axis. It's the point where that happens. Alright, so if I were to draw, let's draw an example. Okay, right there where the graph touches the y-axis, that would be my y-intercept. Alright, for quadratics, they are written in standard form, so ax squared plus bx plus c. Okay, the y-intercept is an ordered pair, and it's always going to be 0, comma something, because if I'm on the y-axis, I haven't moved left or right at all, so my x coordinate is 0. If I were to plug 0 in for the x's here, alright, that would make this term 0, and it would make this term 0, which would mean they would go away, because I would have 0 plus c. So whatever c is, whatever that number at the end of your equation is, that's the y-coordinate of the y-intercept. So if I have y equals 2x squared plus 3x minus 7, to find my y-intercept, I know it's going to be 0, and then I'm just going to take this number at the end. So 0, negative 7 is the y-intercept for this equation. The x-intercept, then, is the point where the graph crosses the x-axis. Now, we did something last week where we found the x-intercepts in the calculator. All right, we called them roots or solutions or zeros, but those are all the same thing. All right, so to find x-intercepts or roots, you're just going to use your calculator. And I'll skip ahead at the end of this video. If you want to skip ahead, you can watch a quick reminder on how to find the x-intercepts on your calculator. Alright, then the last little thing that we need to review, domain and range. Okay, domain, remember, is the all possible x values. Alright, so if I were to look at the graph of a parabola, okay, there is no limit to the x values because I can go forever to the left and I can go forever to the right and I can pick any x value I want. So we call that all real numbers. Okay, and there's also two ways that you could see it written. We could say that x is an element of the real numbers, okay, and that's what that means. X is an element of the real numbers, so all real numbers. So you could see it written this way, and you could write your answer this way. We could also see it written in what's called set notation, and so we would say that x has to be between negative infinity and positive infinity, okay, the little sideways 8 looking 00 thing, whatever, that's an infinity symbol. Alright, so either x is an element of the real numbers or x is between negative infinity and positive infinity because any x value will be somewhere on that graph. Then range, remember, is all possible y values. So if I look at this graph, it goes up forever, so I can have any y values up here, but there is right there a minimum y value. Nowhere on this graph will I have y values that are down here. Okay, so if I have a parabola that opens up, all right, the range has to be greater than or equal to whatever the y-coordinate of this point is, and the y-coordinate of the vertex is the minimum value. Alright, so y can go up forever, but it can only go down to the vertex. If the parabola opens down, okay, this time it has a max. Okay, so y can go down forever, but it can only go up to right here. So y would have to be less than or equal to whatever the max value is. Alright, so when you're finding range, you have to decide whether the graph has a minimum or a maximum. Now, if you have the graph, it's really easy to look. If it opens up, it has a min. If it opens down, it has a max. But if you just have an equation, alright, without a graph, you can do one of two things. You can graph it on your calculator and look at it, or here's a little trick. If the x squared term is positive, that graph would open up. If the x squared term is negative, then it's going to open down. Okay, this is just going to be a real quick reminder of how to find roots on a calculator. Hopefully you have your calculator instruction sheet. It's on our Google Drive folder that's on Fusion if you've lost yours. I would recommend printing one of those out because there's things that we did at the beginning of the year that you might not remember, but you'll need to know for your SOL and final exam. Okay, so x squared plus 6x minus 16, we're going to use the calculator to find the roots of this equation. Alright, the roots, remember, are also the x-intercepts. So I'm going to go to graph from my calculator. It's option number 5. It might be something different for yours, but if you press menu, find the one that says graph. Once I get there, I'm going to type in this equation. So x squared plus 6x minus 16, if I hit enter, and then I want it to draw. Okay, so there is my graph. Now, right now, I can only see one root. I want to be able to see both of them. Let's see what happens if I change my viewing window by pressing F3, and I'm going to go to standard. Alright, that takes me back to my standard window. So if I press exit and then draw it again, now I can see both roots. and I want the calculator to find them for me. So remember, all your options are F5 GSolve, and root is what I want. Alright, so there is one root at x equals -8, and another root at x equals 2. Okay, so my roots are x equals -8 and x equals 2. If I were going to write them as x-intercepts, it would be -8, 0, that's the ordered pair, and then 2, 0. Alright, those directions, step by step, button by button, are on that calculator reference sheet that you can print from Fusion. Alright, that's it for this video. No Google form because this is just for people that were absent or need to go over what we did in class. But there is a 9.2 video, so make sure you watch that so that you're ready for next class.